The given problem, find a city with the smallest number of neighbors at a threshold distance. They are n cities numbered from 0 to n minus 1 given the array edges where edges of I from I and to I weight of I represents a bidirectional and weighted edge between cities from I to I given the integer distance threshold. Return the city with the smallest number of cities that are reachable through some path whose distance at most distance threshold. If there are multiple s- such cities, return the city with the greatest number. Note the distance of the path connecting cities I and j is equal to sum of the edges weights along that path. So here in the given diagram, it is a bidirectional graph. So we can use graph representation list of adjacency list, and then we will add the zero based index and with the weights such that from to and weight, and it is bidirectional, so we'll add from both sides. So and here the 0 is connected to 1 and 1 is connected to 3 and 1, like that. So the adjacency list representation for this is the 0 is connected to 1 and 3, and the 1 is connected to 2 and 1, and also 3 and 4 array, and 2 is connected to 3 and 1, and also 1 comma 1, and 3 is connected to 1 comma 4 and 2 comma 1. So here this is the source list of I, it is the source, and then in the array the 0 array of 0 is the, this is the destination, and here it is the weight. So then we already saw the Dijkstra algorithm in network delay problem. Similarly, we will take the priority queue. Since the approach we need to find the conditions. First, we need to find the shortest distance from the every source. For every source, whether it is any node, we need to consider all the shortest path. Then only we can say what are the neighbors at a threshold distance. So for that we took the priority queue, and then we fill the array with the maximum values. Distance starting is a 0 assumption, and then we add it to the priority queue and perform Dijkstra algorithm. Then we'll poll that, and if we'll explore all the nodes, and then if the distance is less than, then we'll update the shortest one. So if so this is a Dijkstra algorithm. First we need to apply, and then the what are the condition we need to consider is, first n is equals to 4, then these are the edges, and we converted that into adjacency list. And then in the explanation they said the city is connect 0 is connected to city 1 and 2, and city 1 is 0 2 3 connected, city 2 is 0 1 3 is connected, and city 3 is 1 and 2 connected. So you can see here the cities 0 and cities 3 are the two neighboring cities at a distance threshold is 4. So here this distance threshold we can find out by using the Dijkstra algorithm. uh, then we need to find out, so there are two cities available, so we need to find out because they already told we need to return the highest index number. So here this is a logic. First we are finding adjacency list representation, graph representation. Then you can do from I equals to 0 to I less than n all the nodes. I'm just finding the Dijkstra algorithm. So the Dijkstra algorithm I'm performing here. This is the code Dijkstra algorithm. So through Dijkstra algorithm, I'm just finding out the count, how many cities that particular source it's connected at a certain distance threshold. Then if once we got that condition, then we will check if my will try to find the city which have the minimum number of neighbors. That too, it should have the threshold distance. Then through that we can return that particular city.